It's time! Hey! Welcome back, Angelinians. I'm here again, Jerome Sibal. I'm with RJ Narciso, but today we're talking about deep foundation. So, first, what is deep foundation? If the depth of footing greater or equal to the width of footing, it is known as a deep foundation. Deep foundation is used where the bearing capacity of the soil is very low. The load coming from the superstructure is further transmitted vertically to the soil. There are three major types of deep foundation, and their uses in construction are discussed below. But another thing about deep foundation is a type of foundation that transfers building loads to the earth farther down from the surface that a shallow foundation does to a subsurface layer or a range of depths. So, for the three major types of deep foundation, we have pile foundation, pier foundation, and well foundation. First, for pile foundation, in this type of foundation, the load is transmitted by a vertical member. This vertical member is known as a pile. These piles are generally made of steel, concrete, and wooden. These days, precast members are used, but we can create these members on site as well. But did you know, main advantages of pile foundation are high load capacity and corrosion resistance. And there's a disadvantage of pile foundation, also acids can damage the concretes and may occur saltwater reactions. If there is soil on it, we cannot keep the building vaccinated on it. So the pile foundation is used. As we talk about pile foundation has its classifications. First, we have according to function, and then second, we have according to materials. As we talk about according to its functions, it is subdivided into two types. We have bearing piles and friction piles. As we go on, we're talking about their advantages and disadvantages as well. First, let's talk about bearing pile. They are driven till hard strata or layer of rock beds. The load is transmitted by columns to the hard layer of soil. Another thing about bearing pile is a device to transmit the load of the building through a layer of soil too weak to take the load to stronger layer of soil some distance underground. Next, we have friction pile. These piles are used where the soil is soft at a considerable depth. The load is transferred to the soft soil due to the friction produced between the soft soil which is in contact with these piles. Another thing, this type of pile utilizes the frictional resistance force between the pile surface and the adjacent soil to transfer the superstructure load. Before we go further, let's talk about the pile foundation advantages and disadvantages. So here's the advantages of pile foundation. First, according to the specification, we pre-order the pile. Second, the pile can be pre-made its length, breadth, its size, according to site use. Third, precast is the process through which reducing the completion time. Then, can be installed in a very large area. Fifth, can be installed in a very long length. Sixth, we can use piles in a place where drilling and holes are not done. And lastly, work of pile is very neat and clean. Then, for some disadvantages of pile foundation. First, we have a pile can be damaged quickly by driving through stones and boulders. Second, piles can be attacked by marine barges in salt water. Third, a pile cannot be above ground level. Next, it is very difficult to know the actual required length in advance. Fifth, vibrations generate when piles are driving which affects the neighboring structures. Sixth, heavy equipment is required by driving the piles. Then lastly, pile is not containable for low drainage. So those are the sum of the advantages and disadvantages of pile foundation. Then we have concrete pile. The piles which are made with the help of concrete are known as concrete piles. The diameter of this pile varies from 30 to 50 cm. Minimum length of this pile is not taken less than 20 meters and maximum it can be taken till 30 meters. Another thing, a pile is basically a long cylinder of a strong material such as concrete that is pushed into the ground to act as a steady support for structure built on top of it.
Concrete piles are manufactured by following two types. Number 1 is precast or the ready-made. Number 2, cast in situ. Precast or ready-made. These piles are manufactured in the factory which is further transported to the construction site wherever it is required. These piles can be bear load up to 800 kN. Advantage of precast piles. Number 1, it saves our time as these piles are ready to install. Number 2, by using these piles, the construction is done at greater speed. Number 3, for these piles, deep excavation is not required. And the disadvantage of precast piles are, number 1, these concrete piles are costly. And last, as these precast members are prepared in a factory and then they are transported to the construction site, the transportation charges are also added, which increases the ultimate cost of these piles. Cast in situ. These piles are manufactured on site where it is to be installed, so it saves money as the transportation cost is reduced. These piles bear load up to 750 kilonewton. Wooden or timber piles. As the name suggests, these piles are made up of wooden, so they are known as wooden or timber piles. For these piles, seasonal timber wood is used. The diameter of the timber pile varies in between 20 to 50 cm. Length of a pipe is taken 20 times that of its diameter. For example, 25 cm is its diameter, then length is equal to 20 times 25. So the total length is 500 cm. The maintenance cost of these piles is more because as it is wood, if it comes in contact with water, then it can be damaged by fungus or white ants. So care has to be taken. Steel piles. These piles are generally in shape of eye or hollow section. It can be easily driven in the soil because it has a very small cross-sectional area. These piles can be used as a bearing pile but cannot be used as friction piles because if we use them as a friction pile, it can sink in the soil due to structural load. Composite pile. When the piles are made from more than one material, they are known as composite pile. These piles are made from concrete and wood. These piles are used in those areas where the water table is up. These piles are used in such condition just because concrete and wood both are good water absorbers. Advantage of pile foundation. Number 1, use of these piles can save time. Number 2, they are very much economical. Number 3, by using this pile, it reduces the needed excavation. And last, pumping of water is not required as we are not excavating much in soil. Pier foundation. A pier foundation is a vertical column of relatively larger cross-section than a pile. The load coming from the superstructure is carried to the hard strata through these vertical columns. They are generally cast on site. A pier is installed in dry area by excavating a cylindrical hole. If the diameter is greater than 0.6 meter or equal to 0.6 meters, then it is termed as a pier. Types of pier foundation. Number 1, masonry or concrete pier. Number 2, drilled caisson. Masonry or concrete pier. This type of footing is chosen when the depth of the hard strata is at 5 meters or less than 5 meters. Also, this type of footing is done when not much heavy load is coming from the superstructure. The masonry work is done by brick or concrete. The size of excavation depends upon the level at which hard strata exists. The size and shape of this masonry or concrete pier depend upon the level of hard strata is present. Drilled caisson. They are mainly in a cylindrical shape, so they are also known as cylindrical foundations. Distribution for drilled caisson is generally carried out by drilling process. This foundation worked as a compression member. The Lord acted on top of these members, so we can say that they are subjected to actual load and which is further transferred to hard layer of soil. Drilled caissons are classified into three categories. Number 1, concrete caisson with enlarged bottom. Number 2, caisson of a steel pipe with concrete filled. And last, caisson of steel pipe with concrete and steel core. Concrete caisson with enlarged bottom. In this, at top which is ground level of cup is provided. Above that cup, brickwork is carried out. Below this cup, a pier is constructed which is further followed by the enlarged bottom which is also known as bell. The angle of this bell at bottom is 60 degree. Caisson of a steel pipe with concrete filled. In this, also at the top, which is at ground level, a cup is provided. Below this cup, at both extreme ends, a steel shell is created. This steel shell is the outer portion. Inside this steel shell, concrete is filled. Caisson of steel pipe with concrete and steel core. The assembly of this type is also the same as the caisson of steel pipe with concrete filled, but not only changed in that in the central portion of the steel core or a rod is fixed which gives more stability to the structures as the weight taking capacity increase due to the steel core.